I can't remember. I think I might have made a mistake. Usually I start with our objectives, and usually then I copy that slide to put it at the end. I might have actually cut the slide and put it at the end because the next one is blank. That was supposed to be the objectives. I was scrambling to get all this done today. But anyways, this one is about polynomial and synthetic division. Which when I say the polynomial division, really I'm just going to say long division. It's long division, the way you remember long division. Okay, that's it. Now, look at this function right here. 6x to the third minus 19x squared plus 16x minus 4. How many zeros would we expect that it has? You look at the highest power, 3. It should have 3 zeros, right? Is it factorable by any method that we know? I mean, for cubics and above, I mean, there's either greatest common factor, there's sum and difference of cubes, so there's quadratic type if it's x to the fourth, etc. Sometimes when you see 4 terms, if you group the first 2 and group the last 2, then something good comes out of that. I could pretty much looking ahead at this one, that's not going to work either. So it's not factorable by any method that we would have known so far, but it is factorable in fact. And usually the way you start a problem like this is you're going to have to put it in the calculator. See if you can identify a 0 by looking in the calculator. And we know what we're looking for there, right? What will we look for? We're across the x-axis. So put that in. You could do it faster than I can do it up here. Put that in the calculator and see if you can find a 0. Yeah. 2. So if you put it in, you know, there could be up to 3 zeros, right? But definitely 2 is one of them, right? From the calculator, you put it in and you recognize that 2 is one of them. Okay, so from the graph, from the calculator graph, x equals 2 is a 0. Okay, but if x equals 2 is a 0, then what is the linear factor? X minus 2 must be a factor, right? That's why when you plug in 2, you get 0. 2 minus 2 is 0. So what we're saying here is this 6x to the third minus 19x squared plus 16x minus 4 equals x minus 2 times something, right? We don't know the something, but there's something there. And what we do is we figure out how is it that we can divide out this x minus 2 and figure out what goes in that second set of parentheses. And we will have 2 options. One of them is again, either polynomial division or long division, and the other one is called synthetic division. Okay. Right, so. Okay. We're good. Good, Pierce? Yeah. Okay, so before we do the polynomial long division, just remind ourselves the mechanics of doing long division, right? And I just made this problem up, but you know, mostly what we want to be asking ourselves are, you know, what are the kind of things you're doing? What are you saying to yourself as you're doing this? I mean, if we divide 11, right, the very first step would be to say, see, 11 doesn't go into 1, but 11 goes into 12, right? It goes in at least a whole number of times. How many times, right? So you say to yourself, how many times does 11 go into 12? And you say 1, so you put a 1 over top of that. And then what do you do with the 1? You multiply that 1 times 11, which means times both 1s, right? So 1 times 11 is 11, okay? What do you do at that point? You draw yourself a line and you subtract, right? So I subtract and I get 1. What do I do next? I bring down the 3, right? So now I've got a 3. Okay. Repeat the process, right? How many times does 11 go into 13? 1 time. Right, so 1, we multiply again, this 1 times both to get 11, and we subtract and we get 2. Okay, then we bring down the 4. Okay, now, how many times 11 go into 24? 2, right? So 2 times 11 is 22, right? I got to multiply 2 times 1, 2 times 1, 22, subtract, I get another 2, bring down a 5, how many times 11 go into 25? Another 2 times, 22, subtract, and 3. How many times does 11 go into 3? It doesn't, right? So what do you call the 3? It's the remainder, right? So whatever is there is the remainder. That's the mechanics of it, right? And it works pretty much exactly the same when you do polynomial long division. You're going to just use the same thought processes as you do it. So now we're going to divide our polynomial, the one we had 2 slides ago, by x minus 2, because we said x minus 2 is a factor of 6x to the third minus 19x squared plus 6x minus 4. It's a factor. So let's go through the process. So the first thing you do, and when you do this, right, unlike when we were saying how many times does 11 go into 12 or something like that, you're only looking at the x and the 6x to the third as you make this decision. And you could say it to yourself like, how many times does x go into 6x to the third? Or maybe you'd say, what would I multiply times x to get 6x to the third? Or you could even just divide, what is 6x to the third over x? 6x squared, right? In one way or the other, you've got to pick 6x squared here, because that's what we're going to multiply by, x, to get 6x to the third. Right? Whenever we do this, I mean, we should be lining up this first term to cancel. Something's wrong if we're not making something cancel. Okay, but that was only multiplying the 6x to the squared times this. You got to multiply by the -2 also. Just like you got to multiply times both digits of 11, you got to multiply by both of these. Right? So what do you get when you do 6x squared times -2? Minus 12x squared. Right? Now, at the same place when we were doing long division on the last slide, what did we do at this point? You subtract, right? So let's draw ourselves a bar and then write this as a subtraction. Okay, now it should be that your like terms are lined up, right? So our x squared terms are right on top of each other here. What is 19x squared minus -12x squared? Right? -7x squared, right? The minus and negative makes it plus. -19 plus 12 is -7x squared. I just say that is like where we make all the mistakes. Okay, right there, you end up with +7 or 31 or something like that. And if it's not something you're going to do well, by all means, do it in the calculator. Do -19 minus -12. Just put it in, get it right. Because I guarantee, I mean, if you miss on that, that's kind of like the very first step. Of course, everything else is going to be wrong. So get it right. Do we got a cricket in here? Okay, what would we have done in the other problem at this point? We just subtracted. By the way, the 6x to the thirds, they cancel, right? So I'm not even showing that. That canceled each other, which they should. Again, that's why we lined it up. What do we do at this point? Bring down the plus 16x, right? Okay, now we are doing that same thought process that we did up here. We're doing now, looking at the x and looking at negative 7x squared. Right? How many times does x go into negative 7x squared? Or what do I multiply times x to get negative 7x squared? Or what is negative 7x squared over x? Negative 7x, right? So there we go, minus 7x. Right? One way or the other, you got to figure that out. And then what do we do with that? Multiply. Tyree? Negative 7x times x is negative 7x squared. And then negative 7x times negative 2 plus 14. Okay? And again, that is a subtract. 16x minus 14x. 2x. That one doesn't have too many minuses going around. That's always the negatives that kill us, right? Okay, now what? Okay. What should we do now? Bring down the negative 4. And then go through the same thought process. What would you multiply times x to get 2x? Plus 2. So 2x minus 4. Subtract. Okay, what do we get? We get 0. What does it mean when the remainder is 0? It means x minus 2 is a factor, which we kind of knew that, right? Because we found that 2 is a 0, x minus 2 is a factor. So when you do this for this purpose, you better get 0 as a factor. So now what we've shown is that 19, let me scroll it down like this. That's too far. Just go once. So now we know this. What's that? Yeah. The 0 means x minus 2 is a factor. Right? And so now 6x to the third minus 19x squared plus 16x minus 4 equals x minus 2 times 6x squared minus 7x plus 2. So now we know what goes in that second set of parentheses. Right? And if we get it to that point, it's a quadratic. So we can always find the last two zeros with quadratic formula. I mean, if these are real numbers, then you have other options. But if they happen to be imaginary numbers, the only way you're going to find those two is by dividing out the one factor that you got, so that you can use quadratic formula on that. Okay. Okay. We're good. We're good. Bryce done? Okay, so let's try the same thing here. We're going to divide x to the third minus 2x squared minus 9 by x minus 3. Okay, and you can see that written in many different ways, right? You could see it just with words there. You could see it like x to the third minus 2x squared minus 9 over x minus 3. That just means divide anyways, right? You could see it with x to the third minus 2x squared minus 9, and they use the division symbol, right? So you can get it in different ways, but it all means divide. Now, here's why this one is a little bit different. So we're doing more on this one than just practicing what we did on the last slide. If you remember on the last slide, that it was important that we always had the like terms lining up like this, right? And we have an issue on this problem because as I write this x to the third minus 2x squared minus 9, I'm missing a power of x, right? Which means as I multiply, if I make a power of a term which has x to the first in it, I won't have a term to add or subtract against. So when you're missing a power of x in between the highest and the constant, then you fill it in with a missing zero coefficient term, right? Just say 0x minus 9. Right? So missing a power of x, fill it in with a zero coefficient term. So it's like a placeholder there. It doesn't change the value of anything. Now we'll do our division and x minus 3. Okay, what do we multiply times x to get x to the third? X squared. Okay, so x squared times x, and then x squared times negative 3. Subtract. What is negative 2x squared minus negative 3x squared? Have x squared, right? It's negative 2 plus 3, which is 1. Okay, bring down the 0x. Okay, and we'll see why this is important. And now, what are we going to multiply times x to get x squared plus x, right? So when I multiply x times x, I get x squared. I multiply x times negative 3, I get minus 3x. Right? If I didn't have that 0x, I might be trying to combine it with a negative 9, right? So now I've given us an x term to do the subtraction with. So subtract. What is 0 minus negative 3? Positive 3x. And then bring down the minus 9. Okay, what do I multiply times x to get 3x? Plus 3. 3x minus 9. Remainder is 0. Okay, so what does that tell us about x minus 3? It is a factor of the polynomial, the cubic that we started with, right? In fact, now we know x minus 3 times this equals this. That's what we found out. Now, at a certain point, we do this so that then we can further solve. And what's in here, I think that's going to have imaginary solutions. I think if you would like graph that, you'd see the 3 is a 0, and you probably looked that the other turning points are above, so there's only one real 0. The other two are imaginary. And you'd have to solve that with quadratic formula. Right? You wouldn't be able to graph it, couldn't factor it. Okay. Good. Okay. What's different about this one? Yeah. It's not written in a standard form, right? So we need to write it in standard form when we divide it. You don't want it all mixed up around and everything, right? So let me do that. This one is 6x to the 4th minus x to the 3rd minus x squared plus 9x minus 3. And we're dividing by 3x plus 1. That was a long one. 6x to the 4th minus x to the 3rd minus x squared plus 9x minus 3 divided by 3x plus 1. Hopefully it'll fit on the page. What do I multiply times 3x to get 6x to the 4th? 2x to the 3rd, right? So 2x to the 3rd times 3x is 6x to the 4th. Now, 2x to the third times 1 is plus 2x to the third. Subtract. Subtract. What is negative x to the third minus 2x to the third? Negative 3, right? Negative 1 minus 2 is negative 3. So negative 3 x to the third minus x squared. Okay, what do I multiply times 3x to get negative 3x to the third? Negative x squared. Sounds right. So that's negative 3x to the third. Negative x squared times 1 is minus x squared. Okay, what happens when I do the subtract? We just get a 0, right? Those have all canceled each other out, but we're not done yet. Right? We still have to bring down, but this is going to be a 0, but we still need to bring down the 9x minus 3. Right? And yeah, we're going to need them both, right? Because we'll bring down the 9x and we'll say to ourselves, what times 3x equals 9x? And we'll say 3. But then we'll multiply it times both. And so we need two terms to subtract against. So yeah, we're going to say plus 3. 3 times 3 is 3x is 9x. 3 times 1 is 3. Subtract. What do you get? Negative 3 minus 3. Negative 6, not 0, right? Negative 6. Right, so is 3x plus 1 a factor? No, it's not. And you could write this in different ways. You could say the answer is 2x to the third minus x squared plus 3, remainder negative 6. Or you might say 2x to the third minus x squared plus 3 plus negative 6 over 3x plus 1. They're the same. The book always does this. It always does this. In the end, on test, if you say remainder negative 6, I'm okay with that. Okay. You're good? Okay. Slow me down. Here's. Need a minute? Good? Okay. Okay, now, synthetic division, you can't always do synthetic division, right? But you can do it in most of the things we need it for. You can, and you will almost for sure prefer it. If I say, who wants to do long division, who wants to do synthetic division, you're probably going to say synthetic division. But what I've done is I've written, here's the long division, right? And we're going to do the same thing with synthetic division here. And you can compare and contrast, how they're similar, how they're different. Notice the way you set up a synthetic division, right? Where did these numbers come from? They're the coefficients of the polynomial that you are dividing, right? The big one. We're dividing by x minus 2. What is it that we put in the bracket to the left there? The 0, right? That's the linear factor. You put in the 0, which is going to give it the sense of being opposite, right? When you see minus 2, you put plus 2. If that said x plus 2, you would put in negative 2. You put in the 0 goes in that spot right there. Okay. Then you go ahead and draw a line, right, like this, leaving a space in between the coefficients and the line, because you're going to be filling that in with numbers. Okay. And then you bring down the 6 below the line, right? You should never have a number written here, never, okay? Okay, now, this is the process, right? Let me see if I can maybe change colors or something to make it stand out a little more. You're going to multiply the 0 times 6, and you're going to put the result here, okay? So 2 times 6 is 12, okay? And then you're going to add these two, right? In a similar place doing this problem, you were thinking divide, but here we're adding, right? And so negative 19 plus 12, negative 7. Oh, don't want that. Right, negative 7, okay? Repeat. 2 times negative 7 and put the result there, right? So 2 times negative 7 is negative 14. Add, you get positive 2, right? Repeat, right? The 2, that didn't take, the 2 times 2, put the result here, and add. So 2 times 2 is 4. Negative 4 plus 4 is 0, okay? So when you've done the whole process, you're going to bracket off that last number. That's your remainder, okay? That's always the remainder. Right. And then these numbers here are the coefficients of a polynomial, one less degree than what you started with. We started with a cubic. These should be the coefficients of a quadratic. So that is 6x squared minus 7x plus 2, which is what we got there. And the remainder is 0, you know, so we determined x minus 2 is a factor. Now, you can't always use synthetic division, okay? You only do synthetic division when you have a linear factor, and that linear factor has to be 1x plus or minus something, right? It could not have been that problem. Because of the 3 right there, you can't use synthetic division, right? You can't put negative 1 as the 0. I mean, as written, you could not do this with synthetic division, right? You couldn't do it if it was squared, or because it wouldn't be linear anymore. And you can't do it if that number is anything other than 1. So you only do synthetic division when you are dividing by 1x plus or minus a number. 1x to the first power plus or minus a number. Okay. Now, this is the book's writing of this. Just, you know, if you have trouble following it all, you know, what I did right there is the same as what they're doing here. But, you know, if you want to go to their graphics are pretty good. You know, you might notice how they wrote, this is what we're dividing, right? X to the 4th minus 10x squared minus 2x plus 4. What do you notice in their coefficients? They had to fill in the missing 0, just like you do in long division. Because there was no cubic term, we fit in a 0, right? That's the same thing as what we had done with the long division. For the 0, since we're dividing by x plus 3, then what goes in the bracket to the left? Negative 3, because negative 3 is the 0, right? Negative 3 plus 3 is 0. And then you bring down your 1 and start multiplying. 3 times 1 is negative 3, add. 3 times negative 3 is 9, add. Negative 3 times negative 1 is 3, add. Negative 3 times 1 is negative 3, add. Remainder 1. Right? And these, since we started with 4th degree, should be the coefficients of a 3rd degree. X to the 3rd, where is it? X to the 3rd minus 3x squared minus x plus 1. Or like I said, if you don't say the remainder 1, see that what they did, they go plus 1 divided by the linear factor. So let's try this. Let's do it another time. I got that right there if you wanted to compare, but I'll do a synthetic division. We're going to divide this right here. Okay. So what are the coefficients I need to write down? 5. Okay. And what goes in the bracket? Negative 2. Okay. To me, everything up to the point of bringing down the 5 is just setup, right? It's just setup. We haven't done anything yet. We're just setting up the problem. Right? And now we're going to do our synthetic division. Right? I'm going to do it quickly because honestly, that's why people like this method, right? Because it is something that goes a little quicker than dealing with the polynomial terms everywhere. Right? Negative 2 times 5 is negative 10. Add. Negative 2 times negative 2 is 4. Add. Negative 2 times 3 is negative 6. Add. Is x plus 2 a factor? Yes. What is the resultant quadratic? 5x squared minus 2x plus 3. Okay. Okay, let's see if there's anything else to say there. Okay, there's 2 theorems that we have to do now. And the one of them is called the remainder theorem. The remainder theorem says that if we do synthetic, let's say that I have a polynomial here. Right? It's better to show the example. That's why I put the example right underneath the theorem, okay? And after we do the example, then we'll read the theorem and it'll make more sense to you. Notice I'm going to try to find the value of the function, this function, at x equals negative 1. So what I've set up is the function coefficients, just like we know how to do, and I put here the x that I'm trying to find the value for, right? So it might have the opposite sense of what you're thinking of because, you know, before we were looking at linear factors and switching the sign. Now, whatever is that value you're trying to find, that's what goes here. Okay, now, do synthetic division. Bring down the 4. Negative 1 times 4, 6. Negative 1 times 6. Negative 1 times negative 9, 9, 1. Okay. By the remainder theorem, f of negative 1 equals 1. Whatever is the remainder when you do that, that's the value of the function. Yeah. We're finding f of negative 1. So whatever is the x, the value you're trying to evaluate the function at, that's what goes in the bracket. Hopefully I did my math okay. Negative 4, 6, negative 6, negative 9, 9. So that's all good. Right? So if you go back, if a polynomial f of x is divided by x minus k, then the remainder is r equals f of k. So it essentially explains it. When you divide by x minus k, normally that k, that's the 0. That's what goes there. So f of k equals whatever the remainder is. We'll do again. F of 4. Bring down the 4. 4 times 4, 16, 26. Oh, this is trying to get hard. 104. 101. 4 times 101. 404. And minus 8, 396. So f of 4 equals 396. Whatever the remainder is, that's the value of the function. And again, these are the problems that they didn't show, right? These are the ones underneath. So you still got the ones that they showed on the same stuff if you want to see some more examples. Are we good? Madison, you good? Okay. I'm not going to do both, but I'd like to do the half because we don't often do with fractions, but you can do with fractions. I mean, you can. Bring down the 4. Right, we're trying to find f of 1/2. So we got a 1/2 in the bracket. A half times 4 is 2. A half times 12 is 6. A half times 3 is 3/2. Add it up. Negative 16/2 plus 3/2 is negative 13/2. So f of 1/2 is negative 13/2. Okay, now I'm going to go back to show you something on a previous slide. Now that we did a half, okay, I'll tell you that you can actually, on a problem like this, right, you could actually do this with synthetic division. You just need this to be a 1x, right? So what you could do, if you had this written as the whole fraction, right, you had 6x to the 4th minus x to the 3rd minus x squared plus 9x minus 3 divided by 3x plus 1, right? You can multiply both the numerator and the denominator by 1/3, right? In the denominator, then you'd have your 1x. So it would be 1x plus 1/3. But you would have to also divide all of those by 3, too. So you'd have fractions everywhere. But you could end up doing synthetic division that way. You know, generally, it's probably easier just to do the long division, which will let you do it. Okay. Oh, yeah. Where? Well, because 8 is negative 16/2. I need a common denominator. Negative 16 plus 3, negative 13. Right, we're adding fractions. Okay. So we'll skip over that one. Okay. The factor theorem is another theorem that comes at the end here, and it says that, you know, if f of x has a factor of x minus k, then f of k must be 0. Well, that only makes sense. That means when you did the synthetic division with the k in the bracket, you got a remainder of 0, which is what you would, we've already been doing that in these problems, right? So let's just show that this works. Because they also have this is the last example. They also have this one other statement there at the end, which says, then find the remaining zeros. So let's see how this one works. First, my polynomial is x to the 3rd. What are my coefficients? 1, 1, 0. It's missing the squared term, so you got to put in a 0, right? Negative 19, negative 30. Okay, and then what goes in the bracket? Negative 3, the 0, right? Negative 3. And then we go like this. Bring down the 1, negative 3 times 1. Negative 3 times negative 3. Negative 3 times negative 10. Add 0. So this is the remainder theorem, right? By the remainder theorem, because that's 0, we just showed x plus 3 as a factor. That's what the remainder theorem is. We kind of already were doing that, not new, okay? Now, what do these represent? We started with a cubic, so these should be x squared minus 3x minus 10, right? Now, if we're trying to find the last two zeros, then you could take that and find the last two zeros. What would they be? Two numbers, the product is negative 10 and the sum is negative 3. X minus 5 times x plus 2, right? So the zeros are 5 and negative 2, right? X equals 5 and negative 2. So if I want to do synthetic division again to show that x equals 5 is a 0, or that x minus 5 is a factor. When you do repeated synthetic divisions, you're going to do it on this row, right? You don't go back up to this one that you did with -3. You already simplified it to this. Just do the synthetic division right here with 5. Right? So if you have to do repeated synthetic division, you do it on the result every time. You don't just keep bouncing up here. Let's just see what we get. Bring down the 1. 5 times 1 is 5. 2. 5 times 2 is 10. 0, which is what we expected. And now what does this 1 and 2 represent? X plus 2, right? So this is x plus 2, which is x plus 2. It's x minus 5 is the factor, 5 is the 0, you put the 0 there. But this was part of the last example, which was the thing that followed the factor theorem. But in their example, the one they showed, which I didn't want to do because I want you to have that as an extra, they gave you 2 factors to show. This one they didn't, but I did it anyways. Just if you're going to do 2 in a row, you just keep working on the result, until you get down to the end. And I guess I probably don't, So here I did have my objectives here somewhere. Oh, I remember what happened. So we did long division, we did synthetic division, and we used the 2 theorems. That was it. And that's the homework. And